So hello students. Now this is our next class of quantitative techniques. In the previous classes we have studied about the LPP, transportation. Now we have a new topic, that is a assignment problem. It is not the assignment which I am going to give you. It is a assignment problem that we have to solve. So in the next PPT we have the objectives, that what we have to study in this lecture, that we will study about the assignment problem, that assignment problem how it is look like. And the second one is the special case of the transportation problem, and the third thing is the assignment problem is an LPP. That means uh, we can solve or we can convert this assignment problem as a transportation problem and an LPP, and there are the methods to solve an LPP, but which method is the best method, that we have to study. So assignment problem, initially it can be solved by the complete enumeration, that is which is ruled out now, because the number of alternatives are very large. Because what we have to do, we have to do the means iterations. We have to find out that okay, this can be the optimum solution, or this can be the assignments, or this can be the assignments. Now there are the different types of assignments which can be ruled out now. That means which we cannot follow. We cannot say okay, this is the best method. That means this method is not used now. Second point is, can be formulated and solved as a transportation problem, but it is not also efficient to solve. The third is that we can convert this assignment problem into an LPP, which is also ruled out now, because it is basically that the number of variables and the number of constants are very large. The next method comes out to be Hungarian method. This is on the based on a scientist name, that the Hungarian method. It is the most efficient method of all the methods. Now basically this is the layout of an assignment problem, that how assignment problem looks like. Like we have done this transportation problem, that the structure of the transportation problem. Similarly here we have the layout of the assignment problem. Here what I am saying, that we have the different type of jobs. We have the two things, one is the job and the machines. What we have to do here in the assignment problem, we have to assign the different jobs to the different machines in order to minimize cost. Or if these are the salesmen and these are the territories, we have to assign the salesmen to the different territories to get the maximum sales. So the objective of this assignment problem either be the maximum or the minimum. Only then thing is that either we have to find out the maximum sale, or we have to find out the minimum cost. Now here we have the J1, J2, Ji, Jn, the Jn jobs, and M1, M2, Mj, Mn, that means n machines. Now what we are doing here, this C11, C12, C1n are the same. That means C11 is the cost of assigning the job J1 to M1. Similarly, C22 is the cost of assigning the job J2 to machine M2. In general, this Cij is the cost of assigning the job Ji to Mj. So these all are the costs of assigning the jobs. Here if you see that the number of machines and the number of jobs are same. This is the basic thing in the assignment problem, that the number of jobs and the number of machines should be same. Number of salesmen and the number of territories should be same. Number of workers and the number of jobs should be same. Because if there is a mismatch, it is known as an unbalanced assignment problem. So the balanced assignment problem in which the number of jobs and the number of machines are same. If it is not same, then we have to use the dummy row or the dummy column to make it a balance. So this is a structure of assignment problem. Now this assignment problem can be converted into a transportation problem. How? So there is a rule of assignment problem, that one job is to be assigned to one person only. Like if I have a job A, this A job will go either 1, 2, 3 or 4. That means A job cannot be assigned to two different people. So only, so one job is to one worker. Similarly, one worker will be given only one job. That means if the worker 2 is here, he can be only given either A or B or C or D. It cannot be A or B both, or C or D both, or B or C both. So what the concept of the work, the rule says in the assignment problem is that we have to assign one job to one person, and the one person will be assigned only one job to one job. So when we are going to convert this assignment problem into a transportation problem, so we have to see the supply and the demand. So the demand of this particular job is only one worker. So demand of job is one, demand of this job is one, demand of this job is one, demand of D job is one. Similarly, when we are talking about the workers, the supply of this worker is only one job. That means this worker can be supplied to one job only. So supply of this worker is one, supply of the worker 2 is one, supply of the worker 3 is one, supply of the worker 4 is one. So this structure is the cost and the supply demand. So this structure is kind of a transportation problem. Now this problem can be solved by the transportation problem, but only thing is that we can solve this by the NWCM or the LCM, but if we are going for the different methods, then it will be difficult to solve the assignment problem with the transportation problem. So what we will discuss, we will discuss the another format. Now this is what the conversion of a transportation problem into a LPP. Since we have already converted this assignment problem into a transportation problem, so like in the concept of the transportation problem, we have converted this into LPP, the same concept will be applied here. Let this x11 will be the variable, that x11 will be the number of units to be transported in the transportation problem. Here I am consider the x11 as the, that x11 is the number of units or number of workers to be given to A. So x11, x12, x13, x14 till x44. So total variables will be how many? 4 into 4, that is 16. And how many constant will be? 4 plus 4, 8. So this minimum Z, because my concept is, my objective is to minimize the total cost. So minimum Z is 45 into x11 plus 40 into x12 plus 51 into x13 plus 67 into x14, and so on. Now each and every worker and each and every job has a supply of 1 and the demand is 1. So x11 plus x12 plus x13 plus x14 equal to 1, and so on. So this is my conversion of LPP. Now if we see that can we solve this LP problem with the LPP, it is very difficult. Why? Because the constants are 8 and the variables are 16. So I have to deal with the 8 constraint, and for the 8 constraint I have to use the 8 different variables, slack or the surplus. And in some of the cases, because here the constraints are of the equal to sign, so we have to use the different type of variable also, that is known as the artificial variable. So that will be more difficult to solve a task assignment problem with the help of a LPP or the transportation problem. So we are not going with the this concept to, that is we are not referring that the assignment problem should be solved by the LPP. It can be, but it is very linear, lengthy problem. So we have another method that is known as a Hungarian method, which we will discuss in the next class. So what we have studied in this class as a recap, that we have studied about the assignment problem, that the layout of the assignment problem, that the assignment problem can be converted into an transportation problem, and the assignment problem can be converted into a transportation problem, LPP. So we have studied this thing and we find out that the transportation problem or the assignment LPP are not very much useful to solve any assignment problem. So we will study the next topic, that is a Hungarian method, in the next class. Now the question comes that what is the difference between the assignment and the transportation problem? How this assignment problem is different? It is not different, but only thing is that it is quite similar. Only thing is that if we have the supply and the demand are same, that is a 1 1 1 1 1 1, so the assignment problem is basically a transportation problem. And what are the uses? Uses can be in the HR, in the marketing, in the sales, because in the sales what we have to find out that we have to assign the different salesmen to the different territories so that the sale can be maximum. We have in the HR, if we are hiring the 5 people, we have to assign the different jobs to the different people. They, each and every person is responsible, or each and every person can take the responsibility of the jobs. The same kind of a jobs can be given to the 5 people. That means if we are talking about in the university structure, then there are the marketing division, finance division, HR division. So it's not only one faculty in the marketing and one faculty in the finance. There are 5 faculty in the marketing department. There are 4 faculty in the marketing department, and each and every faculty can teach all the subjects, but with a different efficiency. Like for example, if I have a specialization in the sales, I cannot teach the marketing in the with the same capacity or the same efficiency. So what I have to do, I have to do the assignment or the allocation in such a way that my all the courses will be covered and the student will be benefited from that. So assignment problem can be used in each and every area where we have to find out that how we can give this job to the this person, or how this should be given to the another person. So these are the books which can be referred for finding the assignment problem concepts, to understand more in detail the assignment problem. Thank you so much.